For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.
This statistic of $50,000 is defined as a point estimate of the parameter. We know that if we take another random sample of 300 families, we'll generate a different estimate of the statistic. How do you present the result? What we do, we set up an interval around the point estimate and state that the true parameter lies in the interval with a specified level of confidence. The problem is that every time we draw a sample of size 300, families will be getting a different average annual family income. So the question is, how do we present the result? And we do that by setting up an interval around the point estimate and attaching a level of confidence with that interval. So we use both the point estimate as well as the interval estimate to convey the value of the parameter. For example, if you estimate that a 95% confidence interval for mean family income is 50,000 plus minus 509, we'll show the computation later. This implies that based on a sample of 300 families, the average family income is $50,000 and with a half width of $509. Half width is also known as error of estimation. So we say with 95% confidence that the true average family income lies between $49,491 and $50,509. So we take this point estimate, add and subtract the half width. The interpretation of 95% confidence interval will be explained through a numerical example in a later module. A 95% confidence interval implies that if we generate 100 such intervals, if you generate 100 such confidence intervals, each one is based on a sample of size 300, get a point estimate, you estimate the half width, add and subtract the half width to get an interval. If we generate 100 such intervals, then 95 of them on average will contain the true mean if you are dealing with 95% confidence level. However, in our definition, we attach the confidence to a single interval. We just generate one interval with 95% confidence and we say the true mean lies in this interval with 95% confidence. But the true meaning is not with a single interval, but with a, on average, 95 out of 100 such interval will capture the true mean. We can set up a two-sided confidence interval if we know the point estimate and the half width. The half width is also known as an error of estimation. So confidence interval is estimated as the point estimate. Then we add the half width to get the one end of the interval and subtract to get the other end of the interval. Half width depends on the variability of the random variable in the study, the sample size used to estimate the sample average, and the level of confidence desired. Based on a sample size of 300, we estimate the standard deviation of annual family income as 4,500. So we collect 300 data points, each represents a family income, and the standard deviation of that data set comes out to be $4,500. The half width for a 95% confidence interval is given by z.025. We'll explain that later. 95% converts into z.025. Z is a standard normal variable. A standard normal variable is a normal distribution with the mean 0 and standard deviation 1. So the half width is given by z.025 multiplied by standard deviation from the data set divided by the square root of sample size. And that comes out to be $509. So $509 is our error of estimation associated with the average and is based on normality assumption for sample average. The 95% confidence interval for the mean or average annual family income is then 50,000 plus minus 509. Remember that the width of the confidence interval increases as you increase the level of confidence. So a 99% confidence interval will be wider than a 95% confidence interval. A 95% confidence interval will be wider than a 90% confidence interval. So as you increase the level of confidence, we get a wider interval. Remember that the confidence interval need not be symmetric around the point estimate. Under the normality assumption, if you set up a two-sided confidence interval, it becomes symmetric because normal distribution is a symmetrical distribution. We may have to use one-sided confidence interval depending on the scope of the problem, and we'll talk about it when we discuss testing of hypotheses.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.